Hello, everybody, and welcome to today's webinar presentation, How to Operate an Enterprise-Scale Apache Kafka Cluster, brought to you by Instaclustr. I'd like to introduce you to our presenters, Ritam Das, Taylor Bliss, and Wade Timmer. Ritam is a solutions engineer at Instaclustr with a demonstrated history of working in information technology and services industry. Ritam is skilled in sales, strategy, leadership, and technology innovation. He even co-founded a startup at Boston University where he obtained a Bachelor of Engineering in Computer Engineering. Taylor is a senior solutions engineer at Instaclustr and has spent half a decade working with open source technologies. At Instaclustr, Taylor works with clients and potential clients, helping with Apache Kafka, Apache Cassandra, Elasticsearch, Redis, and PostgreSQL. Wade is a solutions engineer at Instaclustr who has experience in software development and IT-related fields. He recently graduated from Miami University, where he obtained a bachelor's degree in computer science. And with that, I will pass it over to our presenters.
All right, thank you. Hi, everyone. My name's Wade. Like she said, I'm an SE here at Instaclustr, along with my fellow teammates, Taylor and Ritam. Today, we're going to go through the challenges of setting up and monitoring an Apache Kafka cluster, and then show you the ways Instaclustr can help with those challenges and make the entire process much simpler. So go on to the next slide here. All right, big challenges. So let's say you have your application running and you need to create a cluster to connect to, right? Kafka has been open source for about 10 years, and there's some good resources online to help you with spinning up a cluster. So how hard can it be? First of all, you need to hire the correct people. These people can be difficult to come by, especially all around the world. I say that because when you're managing a Kafka cluster, things can happen at any time of the day, obviously. So you need to have people online at all times. Next, setting up and managing infrastructure can be a challenge, of course. For example, like choosing the correct instance type for your cluster, or looking at the right metrics to see how your brokers are performing. What kind of things do you need to be looking at? Those are the questions you should really ask yourself. Then for security, missing steps or not configuring things correctly can hurt you down the line. Using features like private IP or private network or multi-factor authentication are just a few of what we consider best practice, but there's a lot more options that can be easily missed. And then monitoring and alerting, arguably the most important things to keep your cluster running. It just happens to be what Instaclustr excels at. For example, like CPU usage sometimes can be misleading. Can happen a nonlinear reaction to actual Kafka workloads. So you need to have an experience and a trained eye to tell what metrics you should be looking at. And then this is true for scaling as well. What metrics should we look at? Tell us when to scale, up or down. What regions should we be covering? All that kind of good stuff. So those are the big challenges. Next slide here. Right, so here's some quick facts about hiring in the data infrastructure world. 13% annual employee turnover comes out to about 600,000 lost for the average company. Looking to hire these types of people, it could be a lot, obviously. 42 days to fill open candidate roles, not very helpful when you want your cluster up and running as soon as possible. And then 58% of IT managers struggle to hire the right people for the job, which I'm assuming could be even higher for Apache Kafka. 125K entry-level annual salary, so that's someone who might not have a lot of experience running these things. And then, like I said before, you need people online at all times, so minimum full-time employees around the world during all hours of the day. All right, I'll hand it over to Ritam then.
Awesome, thank you, Wade. All right, so here you have a timeline of setting up your own cluster. Could take anywhere from 0 to 9 months. Obviously, those aren't hard bounds. It could take a little shorter, and it could very well take a lot longer. But yeah, so listed there are just some of the challenges and complexities in the initial setup of your own cluster. And highlighted in blue are some of the things that I'm considering to be even more difficult challenges that come up when setting up your own cluster. So just to summarize, I'd say a lot of the complexity is in the initial setup and on the infrastructure side. So you have to size your clusters based on planned use cases and planned volumes of data that come in and that are being processed. And then you also have things like security monitoring and general environment startup scripts, using Kubernetes with that. That's also a pretty hard part. And then also incorporating it and using Kafka with other code projects and pieces. You have to assess how messages are read and written to a Kafka topic. And if you're using schema registry, you have to make sure your code can handle utilizing that as well. So things like message timeouts and data replication, and all clusters needing to reply, things like quorum. And so these things can all have an impact on how quickly a message gets written. And it also impacts how safe your data is from data loss and a major failure. But yeah, the big three are really infrastructure related, security and monitoring, and schema registry. These are some of the biggest challenges when creating your own cluster. All right, so here I just have a few bullet points on creating your own Kafka cluster, some of the things you'd want to look out for. So you want to get the right size cloud infrastructure right the first time, because getting it wrong can be costly. We've seen many customers here at Instaclustr come in with oversized cloud infrastructure, just leading to them throwing away money on cloud costs. You'd also want to install and configure Kafka clusters, Zookeeper, and producers and consumers accordingly. Zookeeper really is a beast on its own. However, I will say that it is slowly being phased out from the Kafka ecosystem, so that's a good note. You also have things like add-ons, schema registry, Kafka Connect, Kafka Streams, and a whole other slew of ecosystem or complementary technologies for Kafka that you'd need to worry about setting up as well. Then also, probably one of the bigger points here, you definitely want to ensure high availability through the proper configuration of relevant metrics and replication. This also probably means you want a disaster recovery plan in place. You also need to set up alerting and monitoring, as Wade mentioned earlier. We do have tools readily integratable for that, like Prometheus and Grafana. Important because how will you know when something goes wrong? And then we also have security, which is also a whole thing on its own as well. So that kind of knowledge extends beyond Kafka. Do you meet your compliance requirements like SOC 2, ISO 27001, FedRAMP, PCI compliance, HIPAA compliant? There's a lot of things to keep in mind, and there are a lot of requirements to fulfill these security standards. And then also, when it comes to creating your Kafka cluster, you'll definitely need 24/7 on-call DevOps engineers so that you can handle any issues that may arise outside of normal operation hours. All right, and so here's a mapping of regions and availability zones across the world. I thought I'd include this because it's important to note that you should deploy Kafka in a geographically distributed manner. I say that because that allows for the highest resiliency. And then within Kafka, you also have this concept of rack awareness, and that's region-based rack awareness. So that can ensure that your partition replicas are spread across the right regions. And to ensure that each region has at least one copy of each message, you're going to need at least 3 replicas. So that way, if you do lose a region, you don't lose any data and you continue your normal operations. All right, here we have a single topic with 3 partitions, P1, P2, P3, and a replication factor of 3. So here we have a partition assigned to each node in each rack. And what this scenario or what this diagram is really showing is just demonstrating high availability with 2 replicas of each partition live, even if the 3rd rack is fully failed, as shown in this diagram. So all your data is still available. And one thing to know, we don't back up Kafka data at Instaclustr, nor does anyone really when operating Kafka. So a failed disk on a Kafka node tends to mean a loss of data. And but in response to that, Kafka does have the concept of replication factor and rack awareness. So if you use a replication factor of 1, you're looking at a good chance of permanently losing data. However, with a replication factor of 2 or more, a replacement Kafka broker will rapidly and consistently stream data from the other replicas, so that in the case of an event, in the event of an availability zone failure, and that's assuming you have the spare replicas as well, Kafka will just re-elect new leaders for your partitions on the remaining availability zones. So this is why we strongly recommend that you use the appropriate settings to achieve the required level of availability. So in this case, obviously a replication factor of 3, meaning 1 replica per availability zone. So in total, 3 replicas and 3 availability zones. But even better than that could be a replication factor of 5 and or a multi-data center setup. But obviously that's more dependent on your use case. And since we have pushed such best practices onto our customers, the replication factor of 3, the loss of an availability zone typically doesn't have much impact. It could have an effect on a performance, but that's also why we recommend not running your clusters close to their maximum capabilities. So obviously you'd want to do that if availability is a priority, which it is. And in general, in such instances, the procedure is really to wait for the cloud provider to fix the problem and then take appropriate measures to recover your nodes. So there really isn't much to do to mitigate that sort of outage, but there are preventative measures you can take to ensure that your clusters will operate normally in that sort of event. So, appropriate replication factor, ensuring your clients behave well during a failover. You can obviously test all these client behaviors in a staging environment. So configuring, your consistency level, having or using quorum, things like that can all act as a preventative measure. So just a note on security now. This is quite a beast of a slide. That is because security really extends beyond Kafka. So to maintain compliance with strict data security standards, you're going to need a security team to continuously patch and update your clusters to maintain some such certifications. So the more products you have, then the more security teams you require. And this is kind of a concern, as Wade mentioned, security is also difficult to hire for, and more Kafka clusters just add more workload. So you'd want to do things like set up in-flight encryption, allowing data to be encrypted when in transit between producers, the Kafka cluster, and the consumers. And then it's also encrypted at rest. And then you'd also have things like access control lists and IAM to secure your cloud resources, and then obviously the encryption for your data security. So using features like private IPs, a private network, multi-factor authentication, these are all just considered best practices. And Instaclustr actually has its own intrusion detection system. So we can detect and notify threats within seconds. And really creating such a system on your own is kind of just a whole nother task beyond Kafka. And you might not think that you need something like PCI compliance, but if a customer of yours is processing payment card data, then you very well must be PCI compliant too. And that can be a time-consuming effort meeting all those requirements. And then obviously without meeting data security standards, you're at risk for stolen data, and just a massively complex issue. So I also included just a sample Kafka architecture diagram, and specifically this highlights data transmission from client to server, and then the authentication between clusters and between brokers. So in this, there are a couple of things to keep in mind with security. You'd want to make sure that each client cluster is in a separate network environment, so no shared instances, and everything's running in a separate VPC. You'll probably want encrypted EBS as well. The option to provision in a private network cluster, no public IPs. That's something that's required for PCI compliance, so definitely very important. Internode encryption, which here at Instaclustr we enable by default. You also want client authentication and client-to-cluster encryption. That would be a requirement for SOC 2 compliance. You want a firewall whitelist that you can control. Some private IPs connecting to your cluster, so VPC peering. You'd want to whitelist and monitor open ports and running processes. That would be Instaclustr's basic intrusion detection system. But again, on your own, implementing your own IDS system is a bit of a task. Then you'd want to make sure your OS is hardened to CIS standards. And you'd also want to restrict your outbound firewall rules, just another PCI compliance requirement. So yeah, those are just some of the things, quite a mouthful, and there's a lot more too. Some of the things you want to keep in mind when architecting your Kafka infrastructure. Okay, so I'll pass it over to Taylor now to talk about cluster maintenance.
Awesome, thanks. So for trying to maintain a Kafka cluster is actually a pretty large endeavor if you haven't done it before. There's a bunch of different things that you have to be aware of and know how to do, or learning while you do it in order to properly maintain it. A few of the things that generally comes into play first is monitoring. So this is going to mean setting something up such as Prometheus or Grafana, or another monitoring tool such as Datadog. That's something you want to use. And then from there, set up alerting to maybe via Twilio to text you or email you, or get to somebody even during, say, 2 a.m. if there's an issue with the cluster. Somebody has to wake up and go fix it. And it could be a massive issue, it could be something small, but generally, if a Kafka cluster is running 24/7, it's important to have proper monitoring and alerting to ensure if an issue does pop up that you're able to fix it. Something else to watch and keep in mind is to ensure that proper replication is present and a backup system is functional. At Instaclustr, we have backups at certain intervals, and we have even different backup methods that are continuous. So if it crashes, the last backup may have been 8 hours ago. So it's very easy to just back it up and get it running again. If there is an issue, the easiest way might just be to get the backup going. Something else to keep in mind is upgrading Kafka for security issues and other current issues that might pop up. Upgrading to our new releases. Something that comes to mind is Zookeeper is currently being phased out, so you would have to watch, and if that's the route you want to go, see the versions and go and try and watch them until Zookeeper actually is ready for production, because as of right now, it's really only for development. Scaling is important. We run almost all of our infrastructure in one of the cloud providers for our clients. So this is going to mean adding machines or making machines faster, and knowing how to do this without too much wasted memory, CPU, and storage. So say you're going to add capacity to your current cluster, knowing if you should add more machines or make your machines faster without having too much waste is definitely something that you need to figure out. Trying to maintain a low network latency. This might seem trivial until you realize you might have multi-region clusters or multiple clusters all over the globe. For example, if you have clients that are global, you may have clients in Europe and parts of Asia and North America. That's probably going to mean different clusters in each region, and then trying to have them be the same via something such as Mirror Maker just induces more of a challenge for whoever's managing it. And then also ensure the cluster is cross-regional, and try and manage it between regions. This comes into play, say that I think last week US East 1 at AWS had issues. So it's always important to be in different zones, different regions, to ensure that if something does happen to one cloud region or one cloud zone, that you are still able to keep going even if part of your cluster is down. Next slide, please. So if you are running Kafka, there are alerts that pop up quite often. Say there's an issue, you'll probably get it. It'll probably pop up, and then from there you'll have to go and try to figure out what's going on and what the effect is and how you could fix it. So some of the most common ones are going to be things such as Kafka consumer group constantly rebalancing, and this happens when more than 10 events happen in 5 minutes for cluster for consumer group rebalancing, and this might lead to an unhealthy cluster, might be too much load, or there is a consumer group that has stopped. Another one is Kafka CPU high IO weights. This happens when Kafka's IO weight is higher than 10% for more than 5 minutes consecutively. There could be a read-write error, or a producer or consumer is getting too many requests. At that point, you have to figure out, do I expand? Do I somehow cut down the requests, etc. Also, or Kafka under-replicated partitions. This isn't really a good one. This could mean a lot of bad things, but the partitions aren't replicated at least to one other follower. Could mean a broker node is down, or there's too heavy of a workload on the current cluster. So when those pop up, it's whoever is managing it and watching it has to decide, what should I do? How do we fix it? And this is where our managed service comes into play, because we take care of all of this for you, which helps a lot. Next slide, please. So for Kafka monitoring, there are a few different things that we monitor for you, and you could always monitor more on your own. But for partition monitoring, things such as active controller count, leader count, offline partitions, and partition count, just give an idea of what's happening within the cluster and ensure that everything is healthy. I'll pass it back to Wade, I believe.
Thank you. Yep. Right. So now let's say you don't want to do that entire thing yourselves. Maybe you want a cluster up and running in 10 minutes. With Instaclustr, we can do just that with like all the correct configurations you need to have a successful cluster. We have a pretty easy to use web interface, but it's not just about that. We've done all the hard work for you. Even connecting the cluster to your application can be done in really any common programming language that suits your needs. And then we have code snippets there to guide you as well. But taking advantage of our expertise is the most important thing to getting it right the first time. We've also configured and tested all of our instance types to suit our customers' needs that we know we can monitor correctly. You also have an option to provision using our API, if that's something you'd like to do, and I'll get into that in the next few slides. And all security and authentication options can be done in a single click as well. So next slide here. So this is maintenance with Instaclustr. It can be done through our console or API with thousands of metrics to choose from, and even the capability of seeing in real time how your cluster is doing. And then we have API documentation we can link to if anyone would like to take a look at that. On top of all this, our team is looking at these metrics all day to see if things go wrong. And chances are we'll know about any problems with your cluster before you actually do. And as far as infrastructure, everything is also maintained on our end. No action needed from you. Next slide there. So this is really quick. This is just our API documentation, just a quick screenshot. It shows you everything from deleting to your status, and then on the right there, as you can see, it shows code snippets. Furthermore, for monitoring, we have integrations with Datadog and Prometheus and links to support pages to help you with that process as well. So now I'll hand it to Ratam for a small demo. Show us.
Yep, sounds good. Thank you, Wade. Let me just get my screen shared here. All right, cool. Yeah, so I'm just going to walk you through just a quick what it looks like to create a cluster using our platform, and then I'm gonna connect to it and then send a couple or produce a couple of sample messages, and hopefully they come across, go through the Kafka broker, and then our consumer that's subscribed to that specific topic will read all those messages that we produced. So let's get into it. Yeah, so this is what the console looks like, what it would look like to create a cluster when you have nothing created yet. So we'll just run through it real quick. We'll do a Kafka demo. We'll choose Apache Kafka. We'll choose AWS as our cloud provider, and we won't use any enterprise features just yet. We'll add our current IP. We'll choose our current version as well. Just a quick note, these are the most latest and stable versions that we're offering right now. And then we are going to choose our default topical replication factor of 3 that I mentioned earlier. And then, yeah, we also have enterprise add-ons, which I won't add for now, just keeps this as a very bare bones enterprise grade cluster. And then obviously you can select for at-rest encryption. We choose our node type as well. You can dynamically resize. There's a lot you can do here. But yeah, we'll just hit the most basic instance type, hit next. Then yeah, we would just accept the terms and create that cluster. It'll provision itself in about 5 to 10 minutes. Luckily, I've prepared one for us already. So this is what it would look like once you have created your cluster, and typically you'll run through that creation process just once. The most important part I would say after that is monitoring and alerting and just general maintenance of the cluster, just secondary operations, I'll call it. So yeah, here we have a CPU usage, disk usage, the summary statistics. We can get things like synthetic transactions as well, just monitoring producer and consumer latency and availability by creating false transactions every 20 seconds. This is just an extra step we take at Instaclustr in monitoring your clusters. So yeah, getting into this demo, here is the connection info. Today I'll be using Python. So yeah, what you want to do is install your Python client. And then here you have your producer file and your consumer file. And these are sort of templates or starter blocks for you to add your application onto and connect to your Kafka cluster. So using these, I just threw them in a file in here. See, I have a little directory here with just a consumer and producer. You can take a look in there and see that it's literally just straight from here. So yeah, let's get into it. So yeah, we'll start up our consumer first, and our consumer will just stay running, looking to consume any messages that come across. And then I'll start up a producer in another terminal here. As you can see, so I'll start a producer here, and the producer is just going to publish a message every 1 second for 10 seconds. And then as you can see, our consumer over here is consuming every message that comes across. So yeah, that was literally creating an enterprise grade Kafka cluster within a couple minutes. And it published all our messages and we consumed all of them successfully. So, and yeah, there's a little walkthrough in our documentation if you'd like to mimic that. You can get started with a free trial as well if you'd like to mimic that. But yeah, I will pass it back over to Wade to talk about what we've learned today.
Perfect, thank you. Yeah, so just a little wrap up. Today we've gone over difficulties of hiring, having a staff member on call at all times. Cloud infrastructure needs to be running and maintained as well as monitored, which is where our Instaclustr expertise come in, like Ratan just showed. You saw those common Kafka alerts, but there's many more that could be important to the health of your cluster as well. Availability important. And then things like Prometheus and Grafana can also be done with Instaclustr if that's something you want to use for monitoring. Yeah, next slide here, real quick. So yeah, if you liked what you saw today, you can go out to our site, so have a free trial, just to see how easy it actually is. I also want to say that we're offering Cadence under our managed service very soon. It's a workflow engine that was recently open sourced by Uber. So yeah, and then we'll get into the Q&A there. So yeah, next slide.
All right, well, if anybody has any questions, now would be a great time to pop those into the questions panel. It looks like we do have a couple that have come in. The first one is, do I have to use a console in the API for monitoring, or could I use just one? Is there one that you recommend?
Yeah, so you can use one or both, or neither. I mean, if you want us to look after your cluster for you, but yeah, we recommend using one or both. Lots of customers use our API. If you have the capability, I'd use that, but by no means necessary. And our docs are pretty easy to follow as well if you're inexperienced with that type of thing. So yeah, that should answer it.
All right, it looks like someone else was asking about a replacement for Zookeeper.
Oh, you can take
Currently,
it.
Kafka is phasing that out. It's not recommended quite yet. It's I believe you can run it in dev, but running the Zookeeper list Kafka in prod is highly discouraged. So, Tom, did you have any comments on that? That I heard you.
No, I thought I heard of something else, but yeah, you got it.
Oh, yeah. So we're headed that direction. I don't know how long it's going to be. My guess is probably a few more versions until something is ready for production, but that will be eventually the way to go. But for now, we highly recommend, and the Apache highly recommends not trying to run Kafka without Zookeeper in any production environment. Even though I do believe that 2.8 was the first version to allow some of the features to work. Maybe without Zookeeper, I've never actually ran it myself.
All right, and another question that we have had come in is regarding high availability. Why would I want a multiple DC deployment?
Yeah, good question. Short answer is that multi DC deployment patterns are typically going to be better than single data center when it comes to obviously availability. But there are other factors too that are better with multi DC deployment patterns. You know, better visibility, better scalability, better flexibility, and obviously I think the most important one here is the just resiliency. There are probably a couple motivating factors behind it, like geographical distribution. Maybe there's some sort of legal compliance implication, or maybe you have a hybrid deployment, or you're looking to migrate. And then obviously the last one, maybe you just need a disaster recovery plan. Obviously multi-DC would help with that. In terms of architecting a multi-DC solution, I believe there you really only have two options. One would be a stretched cluster, which is literally just one Kafka cluster stretched across multiple data centers. Or you could do a multi-DC active-active or active-passive deployment pattern using replication and mirror maker 2. So I think that should answer that.
All right. Someone is asking how cost effective are the managed instances of Kafka?
Yeah, I mean, so we charge the cloud costs, and then we charge a fee for managing it. If you compare it against running it yourself, it's going to be quite cost effective. The other comparison might be, for example, Confluent, which is going to cost generally more only because they will charge you, they'll try to sell you the premium version of Kafka. We run pure open source, so in terms of hours to the cost we charge to manage it, it's pretty insignificant. So it's time-wise for running it. If you want to run it yourself, it's going to be less expensive, but then you have to run it yourself, and that takes away a lot of the purpose of having managed service in the first place. But overall, the cost is fairly pretty small compared to doing yourself, and the cloud costs, which you'll pay either way unless you have on-prem infrastructure that you can use.
All right, and then the next question is, you talked about AZ outages and broker failure, but what about total zookeeper failure?
Yeah, that's a good question. So we did talk about availability zone outages and broker failures, but obviously there's one thing else that could fail that's pretty significant here. That would be zookeeper. So in the case of total zookeeper failure, we do backup Kafka. I think Taylor mentioned this earlier. We do have a continuous backup running every 24 hours. So we are taking backups of critical Kafka configs, and with that we can restore to a new Kafka cluster, and that backup is usually just zookeeper transactions, which is all you'd need to restore zookeeper. It'll also contain things like topics, configs, users, your access controllers, passwords, etc. But yeah, we do have that backup running every 24 hours, and then it's being collected by some sort of object storage through any major cloud provider. But yeah, to clarify, we do not back up anything from Kafka itself. We don't back up the messages specifically. We back up the config to restore a new cluster. But if you did need to back up every individual message, if there was a need for that, it's not very common, but if you did, you could look into using an S3 connector, Kafka Connect connector, in conjunction with Kafka. And we do have some resources up on Instaclustr.com that could help you with that.
All right, it looks like we've had one last question come in. Someone is asking where they can get the cost benefits from your company, and if there's a page on your website perhaps that has this resource information.
Sure. So the cost benefits, I mean, if it's going to be a small personal cluster, I invite you to just look at the pricing in the console. If it's going to be a larger cluster, I invite you to contact us. Typically what we do is we'll go in and look at a large cluster. And then something I do actually probably half the time for a company is I'll see the current cluster and they'll be oversized. So right away we're saving quite a bit in the cloud cost. But most of the savings isn't going to come from, I mean, if you're trying to get your cloud costs as low as possible, running through us isn't going to happen. But if you compare the engineering hours you're using or the time you're wasting, or I mean, there's a lot of different resources that go into managing a Kafka cluster. For our cluster, getting it up and running is going to be instant. The only thing that won't be easy, for example, is maybe the security setup initially if we're running it in your cloud environment for like a critical cluster somewhere you have. But you have to look at really your engineering time. I mean, I know most companies don't have an abundance of engineering time. Their engineers are typically being utilized fully, and then how much time would it take you to get to a point where you can actually run it yourself? I know we charge for a consultant. You're probably looking at $200 to $300 an hour for Kafka. That's just my guess. So if you consider the cost of either hiring somebody or not us, but somebody else, or you could also hire us, trying to figure it out on your own, the cost take the hours that you think your engineers are worth, maybe $100 an hour times how many hours do we think to get it up and running, and then the maintenance involved, and then any risk involved, and you can compare that to our management fee, which is relatively low when you look at it all in the bigger picture. If you're looking from a pure cost standpoint and your goal is to get the cost as low as possible without any regard for time or efficiency, your best bet is just to run it yourself on the cheapest cloud instances you can find. But in terms of cloud, in terms of savings, I would need to know, what are you comparing it to? I'm happy to help with that. If you want to email me or somebody else on my team, we're happy to help with that. But a cost comparison, I need to know like what is are you comparing it to what you're currently running, or because we can definitely make it more efficient, but without knowing what the other thing is, it's hard to give an answer.
All right, and that looks like that. Oh, wait, we had just one more question come in, actually. What is the worst incident that you've faced and how long did it take to recover?
I mean, I won't say it's our incident, but something like last week, Amazon's US East one of the US East having issues. That's always bad because we can't actually do anything. We're stuck telling our clients that Amazon is fixing it, and we typically do whatever we can to keep it going. But at the end of the day, the worst incidents typically are if a cloud provider goes down, because we can't actually help anybody. As for ours, we try to fix things relatively quickly. We have engineers globally. We can have them start working on it. And typically our worst cases are going to be a client specific case where something goes wrong with their cluster because of what they're doing. But I'd have to say the cloud providers going down is the worst case scenario, and that we can't really do much except try to mitigate damage for our clients.
Yeah, I'll just add on to that. There are a lot of preventative measures that we kind of endorse and suggest that do, act as preventative measures for these scenarios. So yeah.
I'll go ahead and say, if you have any questions, feel free to email us. If you have a cluster you're curious about possibly being managed, or even other open source tech, feel free to email us. If you just have general Kafka questions, we'll try to answer them as well. But feel free to contact us for anything, or any questions you might have about Kafka or anything related to it. Be happy to help.
All right, well, DZone would like to thank Tom, Taylor, and Wade for a fantastic presentation. DZone would also like to thank Instaclustr for providing the audience with a great webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.